Hey everyone, and welcome. Have you ever really stopped to think about the secret life of a variable in your C code? I mean, where does it actually live? How long does it stick around for? And who even gets to talk to it? Well, today, we're going to pull back the curtain on C storage classes and answer those exact questions. This right here is the big question we're going to tackle. And it might seem simple on the surface, but really getting this is the key to writing C programs that are just better, more efficient, way fewer bugs, and a lot more powerful. And the answer? It all comes down to mastering 4 simple keywords that control a variable's entire existence. Okay, before we dive into the keywords themselves, we need to get a handle on the 2 core rules that govern everything. These are scope and lifetime. Honestly, you can think of these as the laws of physics for your variables. First up, we've got scope, and scope is all about visibility. The easiest way to think about it is this. From where you are in your code, can you see this variable? Can you use it? For example, if you declare a variable inside a function, its scope is stuck inside that function. You just can't see it or use it from anywhere else. And then we have lifetime. This one's all about persistence. It answers the question, how long does this variable actually exist in memory? You see, some variables are really fleeting. They're born the second a function starts, and poof, they're gone the moment it ends. But others, they stick around for the entire run of your program. All right, with those 2 rules locked in, let's meet our first pair of storage classes. I like to call them the local crew, because their entire world is basically confined to the block of code they live in, which is usually a function. So first, meet auto. This is the storage class you are using constantly, and you probably don't even realize it. Anytime you declare a variable inside a function, like int counter equals 0, you're making an auto variable by default. Its scope and its lifetime are tied directly to that block of code. As soon as the program leaves that block, that variable and the memory it was using are gone. Now, its partner, register, is really interesting. This keyword is just a hint for the compiler. You're basically saying, hey, compiler, listen up. I'm going to be using this variable a ton, so if you could, please try to keep it in a super fast CPU register instead of regular memory. It's just a request, not a command. And to be honest, modern compilers are so good at optimization, they might just ignore you and make an even better decision on their own. So to kind of sum it up for this crew, both auto and register variables are local. They live and die within their block. The only real difference is where you're suggesting they should be stored. Auto is your everyday workhorse, living in main memory, while register is your hopeful sprinter, aiming for a spot right in the CPU. Okay, so that's the local crew, but what if you need a variable that has a longer memory? What if it needs to survive after its function is over? Or maybe it needs to be seen across totally different files. Well, for that, we need to call in the persistent team. This is static, and it is so incredibly useful. When you declare a local variable as static, you're giving it a superpower. It keeps its value even after the function call is over. Now, its scope is still local, only that one function can see it, but its lifespan stretches across the entire program. Think about a function that needs to count how many times it's been called. A normal auto variable would just reset to 0 every single time. But a static counter, it would remember its value, ticking up with every single call. Pretty cool, right? And then there's extern. This one is completely different because it doesn't actually create a variable. Instead, it's more like a promise you make to the compiler. It says, hey, just so you know, I'm going to be using a global variable called global count in this file. Its actual definition, where the memory is set aside, is in some other file. Could you just link them up for me? This is absolutely the key to sharing global variables across a big project with multiple files. So here's the biggest difference you need to remember. Both static and extern variables last for the entire program run, but their purposes are total opposites. A static variable defines and creates a private persistent variable. It gets its own memory. An extern variable, on the other hand, just declares a reference to a public global variable that was already defined somewhere else. Defines versus declares. That's the takeaway here. And there you have it. Auto, register, static, and extern. See, these aren't just random keywords you have to memorize. They are a complete toolkit that gives you really precise control over the life and the visibility of every single variable you create. Let's do a super quick final recap. Auto is your default local variable, gone when its block ends. Register is pretty much the same, but you're giving a little hint for more speed. Static stays local and where you can see it, but it keeps its value for the whole program. And extern, that's your window into global variables that live in other files. Each one solves a very specific problem.
By understanding a variable's scope and lifetime, you've really moved from just writing code to actually architecting it. You can now make conscious, smart decisions about memory, about performance, and about structure. So the real question is, with this whole toolkit in your hand, how will you choose to control the secret life of your variables?